For page 86 of your interactive notebook, if you will please title it Geometric Sequences, and then cut and fold your foldable so that it looks like this. So for a geometric sequence, we have also another explicit formula and recursive formula, just like for arithmetic. So for your explicit formula, we talked about this in class. It follows similar to your y equals a times b to the x for an exponential function, because with a geometric sequence, we have our multiplication by the same number, so therefore we can use that same information that we learned about exponential functions to write the formula. So y gets replaced with a sub n. A, which was your y-intercept, gets replaced with a sub 0, the 0th term in the sequence. B is your multiplier, it gets replaced with r raised to the n power instead of the x power. The textbook formula uses a slightly different one. It's a sub n equals, instead of using the 0th term, it starts with the first term. It multiplies it by r still, but now since you moved one space over to the right, you're going to start with r to the n minus 1 rather than r to the n. For the recursive formula, we have a sub n, which is the next term in the sequence, equal to a sub n minus 1, which is the previous term in the sequence, times what's called your common ratio. We represent that with r, which would be like your multiplier in the y equals a times b to the x formula. Again, you have to give it a starting position, so a sub 1 equals some number. You can give it a sub 2, a sub 3. You just have to give it one term of the sequence in order for you to be able to use the formula. All right, so if you'll go ahead and open up that first tab that says a geometric sequence. So a geometric sequence is a sequence where the ratio between any two consecutive terms is constants. That means you're multiplying by the same number or dividing by the same number from one term to the next. Think exponential functions when we were talking about those, linear versus exponential. This constant that you're multiplying by, which would be called the multiplier in an exponential function, is called the common ratio, and it's represented by the letter r. In this example, we have 2, 4 thirds, 8 ninths, 16 27ths, and so forth. A1 will be represented by 2, A2 by 4 thirds, A sub 3 is equal to 8 ninths, and so forth. So if you try to figure out what you're multiplying by to get from 2 to 4 thirds, 2 becomes 4, and then there's a 1 at the bottom that becomes 3. So I think it's 2/3, so I'll try it on the next one. 4 times 2 is 8, 3 times 3 is 9, 8 times 2 is 16, 9 times 3 is 27. So it seems like it is going to be 2/3 for my r. Now, if I'm not sure how to figure out what they're multiplying by, you can take any two consecutive terms and divide the second term by the previous term. So a sub 5 divided by a sub 4, a sub 4 divided by a sub 3, a sub 3 divided by a sub 2. Since these are fractions, you would do keep, change, flip, and if you were to do that, you would get 2/3. So we now know that r is equal to 2/3. When writing these using the explicit formula, you've got two formulas you can choose from. I don't care which one you choose to use. So we have the one that we can use based on our exponential functions, y equals a times b to the x, where a would have been the y-intercept. It gets replaced with a sub 0, the 0th term of the sequence. And b, remember, was that multiplier. It gets replaced with r. And then x gets replaced with n. So in this example, we're going to write the explicit formula for the sequence a sub n equals 3, 6, 12, 24, and so forth. So in this example, you want to first figure out what r is. So it seems to be that we're multiplying every term by 2, so therefore we know that r is going to be equal to 2. And we have a sub 1 equal to 3. So now if we put all that together, a sub n is equal to a sub 1 times r to the n minus 1. That's the textbook formula you can use. Or if you go back one term to get a sub 0, that means instead of multiplying by 2, you've got to divide by 2 to go backwards. So we know a sub 0 is 3/2, which means a sub n is equal to a sub 0, which in this case is 3/2, times r to the n instead of n minus 1. So either of these explicit formulas would work for this particular sequence to generate these numbers. And then for the last tab, talking about the recursive formula, Remember, a sub n is represented by, it represents the next term. A sub n minus 1 represents the previous term, and r is that common ratio. You do have to be given at least one part of this to be able to begin, so you would have to say a sub 1 equals some number, a sub 0 is equal to some number, and so forth. So in this case, a sub n is equal to negative 5/12, comma 128, comma negative 32, and so forth. So we want to write the recursive formula for this example. So if you're not sure how to get from negative 5/12 to 128, 128 to negative 32, and so forth, you can take any two consecutive terms and divide them. So a sub 2 divided by a sub 1, or a sub 5 divided by a sub 4. When you divide those two terms, you're going to get negative 1/4. So we know that r is equal to negative 1/4. So I can now give the formula a sub n is equal to a sub n minus 1 times r. So I would have replaced this a sub n minus, I would have replaced this r with negative 1/4. So this is now saying that the next term of the sequence is equal to the previous term times negative 1/4. And then you can give it any term in the sequence that you want. In this case, I gave it a sub 1, which is equal to 5/12. So this would be the answer for the recursive formula. And that's it for this page.